Hey everybody, happy Friday. Since I'm unable to have live classes today, we're just going to do a really short recording to kind of emphasize the main points of today's lesson and just make sure everybody's on the right track. So today the lesson's all about looking at what causes elements to react with each other. Why is it that sodium reacts with chloride and not some other element to make a salt? And as we look at it, it's all about their electrons, how many electrons they have in their outer shell. We've been talking about that. And to remember that atoms are always trying to get their energy levels full. Their goal is to have full energy cells because when they're full, then they are stable. And that is kind of the why they combine the way they do. An important thing to remember, though, when we're talking about these energy levels, is to remember that as electrons are added to the nucleus or to an atom, they always are added in order. So the lesson had a really good example of these bowls that are fitting inside each other. You know, yes, I could put the blue bowl inside this yellow bowl, but I have to do it in order to get them all to fit. And that's kind of the same way with electrons. They start in the inner one, fill it, then they go to the next one and fill it, then they go to the next one and fill it. They don't do like one here, one here, one here, one here. Okay? So that's important to remember. And then also the idea is to remember that everybody wants to be stable. And for atoms, except for that first shell, remember, so that's except for hydrogen and helium. Those are your two exceptions. Everybody else, the magic stable number is 8. They want 8 electrons in their outer shell. And since it's that outer shell that matters, it's what's out, kind of opposite when we talk about beauty's only skin deep. Well, in electrons, it's on the outside. It's the only thing that matters. And it's what's on the outside that gives it the properties that it has. And we've been talking about it in these terms of electrons in the outer shell, and that's kind of a long phrase. So we come up with, science likes to come up with terms. What we call it is valence electrons. So that's just the formal name for the electrons that are in the outer shell. So anytime I ask you how many valence electrons does something have, what I'm asking is how many electrons are in the outer shell. So that's valence electrons. And, we've kind of been talking about how the periodic table has this neat pattern. And so that is one of the things we can look at in the periodic table. It shows us this pattern of filling of the shells. So everything in the first group or the first column all have the same number of valence electrons. So all of them here have one valence electron. In the second group, they all have 2 valence electrons. And remember we said down here in the transition metals, let's skip those and then go to this boron aluminum group. These guys have 3 valence electrons. Carbon's group has 4 valence electrons. Nitrogen has 5. Oxygen group has 6. Fluorine's group has 7. And the noble gases over here are the ones on the far right. Those all have full energy levels. So that's why they put helium there. It has a full energy level, full outer energy level, I should say. And so, you have to be very careful. Am I asking how many valence electrons there are, or am I asking how many more it needs to be stable? So if this last row are all stable, if I were to ask about any of these here, how many more do they need to be stable? Well, they're only one away, aren't they? If I add one more, they're stable. Same with oxygens. How many more does oxygen need to be stable? Well, it's 2 away from the stable column. So it needs 2 more. So you got to be careful. What thing am I asking? Am I asking how many electrons are in the outer shell, or how many more does it need to be stable? So those are 2 things we're concerned with. How many does it have? How many more does it need? Okay, and something we're going to be getting into, you saw in the video that you watched yesterday. If you haven't watched the video yesterday, you need to do that. And it's dealing with these Lewis dot diagrams. They're just a really quick notation, a quick visual way to see how many valence electrons are in a particular atom. And so, for example, and we use the chemical symbol, so O for oxygen. Oxygen, as we look at it, its outer shell, it has 6 valence electrons. It also has 2 on the inner shell, but remember, we're not concerned about that. All that matters is what's on the outside. So we put a dot for each electron that's in the outer shell. So you can see there's 6 here. 1, 2, 3, 4, 5, 6. So whenever you're looking at a Lewis dot diagram, you're looking at how many valence electrons does that thing have. Okay? And we'll talk more about this next week, and we'll start drawing out different Lewis dot diagrams. And the neat thing about Lewis dot diagrams, once we get the hang of these, then I can say, I can see right away, okay, hydrogen has 1. And so, hey, if I were to put hydrogen here at the top and hydrogen here at the bottom, they'd all be complete. So that's what Lewis dot diagrams help us see, is how the atoms combine in compounds. Okay, so today what you need to do is make sure you're completing all of the activities in this week's agenda. So that means make sure you've watched both videos, the one that was linked into Monday's homework, the one that's linked into Wednesday's homework. In fact, let me grab that and show you what I'm talking about. Okay, so make sure you're doing all of these assignments. Make sure you have completed the Unit 5 assessment. Make sure you have done the PowerPoint. Make sure you've watched the video, that you've done your constructed response, you've done the worksheets, you've looked at the lessons. So today, if you haven't done any of these, if there's something you're missing, get it done today. That's the first thing. The other thing is make sure you submit the worksheet. The worksheet is due today. We started it on Wednesday, so get it finished today. And of course, if you haven't completed the constructed response, I would advise watching the recording. I've got it linked into your feedback if you haven't finished it yet, because we straight out just tell you what I'm looking for. So watch the recording if you were in class. Okay, and there's a couple things I wanted to point out in the worksheet for today. So let me move this over. No, I didn't want to do that. Okay, in the worksheet today, notice this question here about the halogens, talking about fluorine, chlorine, bromine. Notice I'm asking how many do they need to be full. I didn't ask how many valence electrons they were. I asked how many does this group need in order to have a full shell. So I've noticed a lot of people are missing this one, and I think it's just because you're not catching what I'm asking. How many do they need so that they're full? And then the Lewis dot diagram, if you've watched the video, this question should be an easy one, but also I said today, the dot diagrams is all about showing the valence electrons. Okay? As always, if you have any questions, feel free to email me. Email comes to my phone, so I will see it today as I'm driving to the airport today. But hopefully this helps you out, and we will see you on Monday morning.